Hey everybody, thank you so much for coming out. And a special thank you to the organizers of SeaGL for their flexibility. Wasn't able to present yesterday, so here we're getting together in the afternoon. This talk is pre-recorded, but I will be available in the chat to answer questions and yeah, talk about this stuff and see if I got the take right. Anyway, let's jump right into it. So this is data liberation, open source observability. We're going to be talking about observability tooling and how we can create observable architectures using mainly open source tools, and about some of the sort of basic concepts that come with that, some of the strategies and tactics for creating more observable systems, and what else are we going to talk about? We're talking about the relationship between open source and telemetry. The relationship between open source and telemetry. Sorry, I don't mean to mumble through that one. I'm going to tweak my camera very slightly. All right, we're getting electrical cables in the shop. That's fine. That's fine. Okay, so who am I to be lecturing y'all about open source observability? Well, I'm Noshnika. Nika is fine if you have a little trouble pronouncing Noshnika. And I work for New Relic as a developer advocate in the serverless and cloud engineering fields. I will say we're going to mention New Relic a couple times here, mainly New Relic sort of, in relationship to other open source tools, and we're also going to talk about sort of other observability companies. This is definitely not a sales pitch. I'm not going to encourage you to use New Relic in this talk. If you want to see more of me, who wouldn't, you can find me on Twitter at ServerlessMom and on Twitch at ServerlessMom, where I tend to be building web applications a couple times a week. Is there anything else I want to say about that? No. Okay, so, oh, this view isn't great. We looked at some. Let me move my video up here. So here is our sort of general plan of what we want to talk about. We talk about defining observability, talk about a goal that costs a great deal of money. We're talking about liberating instrumentation, the three pillars of observability. We're talking about storing data in data basins, and about turning data into knowledge. Okay, so let's talk about defining observability. We don't get this exact question that often, what's an observability and where can I buy one? But there is a sort of misunderstanding around this term. It's a big buzzword on the West Coast, so I'm sure you've all sort of heard it. And it can kind of come off as like, well, this is just a souped up version of logging, or it's like a really good version of monitoring. And also, like, a couple companies have become closely associated with the term and sort of fought over what it means. Anyway, that's me getting too deep into my world. But my definition of observability is pretty simple. It's just a sort of combination metric that observes how quickly you can get to understanding. So observability as the time to your understanding. So when you have a problem, let's say you have a failure, you have an outage, maybe you have something reported by your support department that tells you that you have some kind of problem. And how long does it take to go from knowing you have a problem to knowing in general where that problem exists? So, there are lots of times when we have observability that's extremely good, where we can say, hey, you take a quick glance at a dashboard, you go and look for a certain thing being logged, or maybe even just ask a certain question of someone. You say, oh, did you deploy to this service and did you do this? Oh, I know what the problem is, right? So in that case, we understand a problem pretty quickly. And those are all examples where, we have very little information is involved. Other times our observability is very poor. Maybe we spend a long time trying to figure something out, and in the end, we just have kind of restarting the service, and then things go back to normal, right? And in that case, right, we maybe have like very, by some definitions, no observability, or we just we don't really understand our system super well. That doesn't. So I mean, the implications of that definition would mean that observability sort of, you always have some observability value. But it's important because I want to define it functionally, because it helps us understand that there's multiple facets that contribute to observability, and it's really not just one thing that you can sort of buy or have and just sort of get. And I think of it a little bit like terms like agile or terms like DevOps, where, it's not a box that you can tick either, right? It's not that you say, well, yeah, we're an agile shop, and that's just kind of the end of it, right? You can pull back and say, well, this is a design ideal that we have, and it's something that we're getting close to, or we're doing pretty well on, or just in other ways we're not doing very well. A bit like the joke, you look down on what you do sometimes and you think, that's so Raven. And other times you do things and you're like, that was not very Raven. Yeah. So observability is sort of a design goal. So there has been this kind of weird state with observability. And another example might be as a goal is like test-driven development, right? And you're starting in kind of boot camps or any other program where we're sort of learning how to build and deploy applications. Observability can get talked about as like, oh, this is something that you need, right? Just like, hey, you need to do test-driven development. You need to have some version of DevOps, right? You need to have the people who deploy services be sort of able to understand and work with the code, and people who understand and work with writing this code, understand how the stuff is deployed. And for those other examples, let's take test-driven development. It would be a kind of odd state of affairs if you were telling your boot camp students, you say, hey, you need to do test-driven development, and then you ask them, okay, well, what do I need to, what's step one? And you said, well, step one to doing test-driven development is you start paying someone about $300 a month. But that is kind of the state that observability has been in, right? Is we say, hey, you should have this ability to look very, very quickly through the performance information for your service and get some analysis of what it's doing and why. And the fact is that really is has been a software as a service or a instrumentation and observation service that costs a good deal of money. Now, in some ways that makes sense because frankly, when you're building test apps, when you're building your demo things, or you have 15 users for your cool new service, it may be that you're really not, you're not thinking about like, oh my God, I'm going to get waking up in the middle of the night and have a problem I'm going to need to solve, right? In some ways this makes sense because it's like, well, it's not until you're making money do you really care about this observability stuff. But yet, what we're going to talk about in this talk, or what we're going to show, is that observability is a design strategy as well. We have to think about how we're capturing and how we're structuring our system so that it's more observable. And so we really like to start that early. So this has kind of been pulling at the observability question quite a bit, that very often when we have talks that are haranguing us about how, we should have this strategy, we have the system, implicitly in that talk, they're often given by people who are saying like, yes, and also you should sign up for the service and it's relatively quite expensive. And so that means that people can't really get exposure kind of early on. There are some reasons why, unlike, for example, test-driven development or infrastructure as code, which is something else we're going to talk about, like deployment templates, observability sat for kind of a longer time behind that paywall. But in kind of the modern context, it probably doesn't make a ton of sense. There probably should be some kind of democratized ability to do that. And sure enough, there is, right? There are, I'm hiding, this says open telemetry here, so I didn't make a safe zone for my video. These open tools really are fully available to do real observability, yourself. And so talking about open telemetry both standardizes how data is sent to show you your performance information, and also is a large project and standard that includes tons and tons of packages of instrumentation. So to talk about that for a minute, there's kind of these functional pieces of what you call doing observability. And we're going to break down kind of the types of things that you might observe. But one of the things that it starts with is it starts with some kind of hopefully automatic instrumentation. So while you can always observe the performance of your code by going into your code and saying, hey, I want to start measuring a time, and right here I want to finish ending it, I want to report it as this value. A lot of people were in the situation sort of because of the path that we talked about of, you don't really care about this stuff until you're making money and your application is growing to a certain size, where, they were sitting and looking at, thousands and thousands of lines of code and like, okay, where are they going to start putting in all these, points of observation? So packages of instrumentation became this very hot commodity. So, something that you could install on your system that would automatically start telling you how like individual functions are performing became a really critical service offering. And so this is one of the reasons that sort of at the outset of observability and performance monitoring tools that you saw a lot of services out there to do this that maybe in parts of the instrumentation package were open, but then the actual service wasn't, and so on and so forth, because that's a tough problem, right? Like, hey, I want to install this little agent or something. I want it to observe everything that happens and label it correctly and give me useful data about performance automatically without me having to go in and edit my application code. What we're seeing as part of the Open Telemetry project is that more and more of those packages now exist as open source, and you can, for things written in many frameworks, you can install something that adds the instrumentation that you need automatically and gives you pretty useful data out. And obviously there's some tweaking there, and you can go in and edit your tools as appropriate, but it gives you that baseline. So that's the open telemetry. We're going to get more into like what we're measuring and why. But yeah, so these projects do exist. Open telemetry grew in part out of Open Census, which was more specifically like a little more scoped to do particular projects. I'm pretty familiar with the Open Census PHP project, which still gets really good data on performance semi-automatically. Now, I will admit that open source and telemetry, and this is not directly related to the open telemetry project in particular, does have a dark side, where I'm kind of talking about, hey, getting woken up by an event on your own service and needing to know like what's going on with it. But there is this other side of it that I think I just want to address. It's really not what I'm talking about in the bulk of this talk, but I want to kind of touch on it briefly. So, there's kind of a classic adage that says, if you're using something and you're not paying for it, if you use this product and it's free, then the actual product is you. And this was coined around television and advertising, right? That, the fact that television was free was just because, the advertising was creating you as the product. You were being created as the consumer inside the consumer society. What we see, of course, more so, right? The reason that Google Docs is free, or the reason that these other services are free, is because information about you is the actual product that's being sold. Oh, sorry. And the way this comes up with telemetry is that, and open source, is that we've seen some incidents recently where, partly in an attempt to make open source stuff financially viable for people to keep working on, we've seen some open source projects that you can download and use for free, but they do include telemetry packages that report up some of your usage patterns to some centralized server. Now, there's been a little bit of confusion about what kind of the motivation for even doing that would be, whether the purpose was officially nefarious, like trying to, report you to the NSA or trying to make trouble for you. It's a little more straightforward than that in my observation. It's that data is very often, it's like the, it's the gold claim of venture capital. And so saying, hey, we do this service and we sell socks to people, well, that's really hard to raise venture capital money and raise investment money. But saying, hey, we do this business and we sell socks to people and we get tons of data about their foot health, and we're the only company that has the real information on people's foot health, that is the thing that gets investors super excited. It's been this way for a decade now. It's still very much this way. So obviously you have the FANG companies are all ones that claim to have this really deep data about people's behavior and information. And so very often people who are producing working for profit and are producing open source tools will see that the way that they can kind of stay in business and grow their business is that they can go and raise a bunch of money by the claim that they can get a bunch of data about people's performance. Now, again, the thrust of this talk is about observing stuff that you have built yourself and that you want to monitor for your own benefit, and not so much about this other telemetry side. But we have to acknowledge when we start talking about collecting data, this is going to be a motivation, right? There is this kind of dark pattern out there that says, rather than trying to do something that has a benefit either directly to me or to others, and that benefit is obvious, there's this desire to do this surveillance to produce something that will get us some investment money that often has no clear profit goal. But again, the idea of owning this data and owning data that nobody else has is this very, very powerful motivator in kind of the business world today. So That's all I want to say about that. Don't do that. I don't know what to say. Don't do that. The community turns on you pretty quickly when you do this. It can often be very, very hard to like walk back and presenting kind of obscure opt-out only, like opt-out optional stuff buried inside an open source project when most people are just grabbing this thing from npm and not thinking about it. Yeah, like it will backfire, and also it's like a pretty questionable like long-term tactic. Yeah, and then we can get into a whole thing about like what that. Anyway, don't do that at all. Okay, so just gonna move my thing and redo this just a little bit. Okay, so there are three components to a well-measured system, and we're gonna go through them here, and they are metrics and other metric observations, logs, and traces. This is Three Pillars by Kandinsky, in case you're curious why I have this sort of abstract forms here. Oops. Hey, you know what? This is what happens when you get the raw and the real recording of me and my life. Is sometimes my phone rings, even though I put it on silent. Oh, that must be my boyfriend. Who's the only person who gets to call me when it's on silent. I hope they're okay. They're fine. They just want to talk about plant stuff. Okay. Three components to a well-measured system. Let's talk about it. Okay. So also this quote from Kandinsky: everything starts from a dot. And as we start to combine those dots, we get metric data. So metric data is, an attempt to observe something in a standardized way that gets a standardized information out. And when we're observing, computational machines, this is quite possible to do, right? We're not guesstimating, we're not picking sort of odd metrics. We're usually just making pretty direct observations of how something is performing. In general, metrics have a greater use for a business than they do for on their own than they do for observability. So when you have a crisis and someone says, well, our RAM usage is at 71%, that's not necessarily telling you that much, right? That's a little bit hard to like use and get much information out of. When we say, hey, the population of this town is 425. Okay, like that's a little hard, but the big uses of metrics is metrics in a time series. When we are trying to analyze a problem, the ability to look at metrics in a time series will very often get us very, very close to a solution, especially when we're talking, again, think about this observability thing of how quickly can we understand a problem. If we can see that a spike or one problem predates everything else, comes first, and maybe causes then we can at least say like, well, this spike that happened before was not caused by the stuff that happened afterwards, right? So we can usually make at least some basic inference from that metric information. Okay, so another big source of data is logs. Logs are, I managed to get myself stuck on this little thought experiment or sort of head scratcher today, which was, are logs or metrics the first observability tool? Which I was like, okay, like release the code, like logging was logging before metrics. I think the answer is actually metrics. I think like you could make observations about early computing, like electromechanical computing, that were basically metrics, that were things of like how fast something was reporting or how much memory was available. And you could do that before there was any kind of like, hey, this is logging out certain events in the behavior. Anyway, whatever. That doesn't matter, but just kind of thinking about that. Anyway, so the thing about the logs is that there's always a lot of logs. So sort of as soon as we got out of the floppy disk era, our ability to store kind of massive amounts of text about what's happening got really high. And so even though, most of us have the practice and are taught the practice in production of like not logging too unnecessarily, not doing a bunch of extra logging, taking out our sort of debug log points, often marking specifically like, hey, I want to see these logs, but only when I'm running on staging or only when I'm running in development. The fact is there's always a ton of log information. And one of the issues with that for observability is like logging is often kind of seen as like synonymous with observability, like ways to store massive amounts of logs, ways to query massive amounts of logs, is that when we're trying to solve a problem, we're very often in the solution of trying to define to a massive, massive corpus of logs what an answer might look like. What would an answer look like? So we're writing a regex or writing a query or something else that we want to get, like, hey, I think it would look something like this. Maybe we're seeing, very common task in, sort of early, operations stuff is like, hey, can you look for the most frequently appearing IP within this massive, massive corpus of logs? And the problem with that is that we ask certain questions, we think they're good, but they don't necessarily always return exactly what we expect to get back, right? This is a classic Diogenes quote, "Behold, I've brought you a man." So when challenging another philosopher to say, define what a man is like, well, it's a biped, doesn't have any feathers or fur on its body. And Diogenes brings back a plucked chicken and says, look, this is what you define as a man. And if you haven't read anything about Diogenes, please do it. So this is like a pretty serious barrier to using logs as a kind of universal solution to observability. And one of the things that I would kind of submit about logging is that logging is the biggest source of where it's possible to add information and actually hurt your observability situation. So my classic diagram is, let's say you went into your code and went to every of the thousands of lines and you added a log line. Let's say you added a comment on every line and you turned each one into a log line. You say, hey, I'm going to log the exact state right here. I'm going to log this information. I would say your observability just went down, right? Because provided that you had any logs before this, it was more likely that those logs were things that were important and worth noting. And now that important, worth noting information is now buried under an absolute mountain of noise. And so, not that people shouldn't log too much or something, or that logging should be limited, but I just want us to realize that logging is definitely part of any observability solution, but we need to be thoughtful about how it actually improves that observability question of how quickly we can understand something. So the new kid on the block is tracing. Tracing is this. Hold on, my dog needs something. Harvey, are you good? You want to go bother? I love you. Tracing is an essential piece of how we understand performance of modern systems. So one of the things about the OpenTelemetry project is the OpenTelemetry project is, from its kind of inception, is about observing like cloud-based and microservice-based architectures. And that's not because it's not good for like a single application. It's just that, and I mean, again, OpenTelemetry is a project. It's not a single repository or something. Hey, bud, do you want me to throw your ball? You just want to hold your ball? I will throw your ball if you give it to me. All right. My dog is here. You want to get on camera for a sec? Do you want to come say hi? Do you want to say hi to the people, or you just want pets? Okay. Tracing, right? So, one of the things to think about is that tracing as a concept, which is tracing is the concept of trying to follow the traveling of a request through multiple components, is actually probably easier to do on a monolithic system. So on a monolithic system, let's say you probably have something like a transaction ID, which really effectively gets passed around. I don't know why I'm like moving my video to show you the bottom of my little monolith drawing. But anyway, I made a little drawing of a monolith, which, I don't know, looks a little more square now. It's fine. Monolithic systems were actually significantly easier to monitor, especially in this case, right? As maybe a transaction gets passed from code point to code point, it's going to be pretty easy to look at the history of that request. Hopefully you have some kind of transaction ID. It may even be, if you have a low frequency thing, that it's just you can look at all of the logs you have in a particular period of time, and it's pretty easy to see that one request getting passed around. But Austin Walker at Lightstep, observes like when an application consists of tens, hundreds, or thousands of services running across many hosts, it is no longer possible to rely on an individual trace. So, while a trace in a monolithic context was relatively easy to stitch back together, now we're just not able to do that as easily. So, this is a screenshot, and it happens to be from New Relic just because that's what I had available to me. But you see, an interface like this all over the place, which is attempting to stitch back a trace of a single request and what services it hit, all into a single story, even when those traces were happening asynchronously and across multiple locations. And so this is where we get into the concept of, usually now tracing is synonymous with the term distributed tracing. So we're trying to have kind of a single observer that is seeing a series of behaviors, all as presented as one narrative, even though they're happening in multiple places at multiple times. And there was a real seed of this in the Dapper project over at Google, which I believe is still used. It's documented in a paper. I don't think you can actually use the project yourself. They're just documenting what its standards were. But Dapper, distributed tracing. Tracing and distributed tracing is a real challenge. And in fact, it can be very easy to get into situations where what you fundamentally have to do to figure out sort of what happened as part of one request is you have to look at multiple things that were recorded and observed and stitch them back together post hoc. So after the request is completed, you're only then able to say, hey, this touched all these other pieces of services. And that is not a design flaw. That's not an error that's occurred in that construction. That's much more an expression of the fact that this system is complex, and the way that we should be engineering our systems is that things like a complex database update, let's say you run like an online school system and you're deleting one of the schools, which in turn deletes the teachers and in turn deletes those students, right? And so you would expect that a request to say, hey, delete a school, in some ways comes back with a response to the user that says, cool, school deleted, but also kicks off other database requests that go to other places. So the observation of, hey, the request is done, maybe when we send a response back to the user isn't exactly correct. The expression that, hey, it's done when the school is deleted is not exactly correct. When we try to tie that together as a distributed trace, that's something that has to happen kind of after the fact. And that requires a relatively sophisticated observer to be able to see, hey, all of these things are related to a particular request. And especially if it's going to multiple places, going to multiple hosts, a lot of the things we used to do to sort of connect these things logically are no longer effective. Okay, so stepping back a little bit, I want to observe that even though there's now really great open tools to sort of grab and instrument and record that data, the fact is that there are other limitations to doing monitoring and observability, which is you sort of have to ask a fundamental question of where does our data go? And I'm not saying this is like a paranoia thing. I'm just sort of saying this as we need some place to actually store that data that we're sending. And I'm sorry, the captions cut off here, but I'll read it, right? With the need for storage, observability can be open source, but it cannot be free. So there is some requirement to go and send that data somewhere that you're observing, often to be able to do some kind of post-analysis, but certainly, of course, to be able to query it to make some observations about that data. And a sort of a conversation that I have kind of repeatedly, especially I talk about cloud tools and talk about AWS and Azure and these other large cloud services, is someone will say, well, I can store all this stuff for free. I can just get a couple of Jazz drives and store all the metrics that I need, and that I really feel this message here, which is that observability can absolutely be open source, but it really can't be free, because even if you say, okay, well, I can do all this stuff myself, you're still accepting the responsibility of running that service and maintaining that service, and that's not a free option. And discounting your time as free is not the way to do FOSS, right? So you need to think that there is some existing cost to whatever tool you're going to use. So another observation about that storage is that the ability to read from that storage is another kind of key component. So This is kind of my big thought on this is right that the speed with which we can read a dashboard has a direct effect on observability. So this is, you're not going to be able to read any of these data labels. They're too tiny here. This is a Prometheus and Grafana observability tool. So again, built entirely open source tools. You need someplace still to store the data. You need to pay for some kind of storage. But this is a very, very, lightweight, not using any kind of SaaS options to store and grab this data. And one of the things I really encourage people exploring Grafana is that the ability to make these readable dashboards is such a key piece of observability. So totally outside of the data that we're gathering, the speed with which we can look at and interpret that data is super, super critical. If we look at this graph here, again, without being able to read the labels, we can start to suspect that there's something going on at this time point here, right? So let's talk about how we're able to do that so easily. One is auto scaling, right? None of these show up as just a minuscule little ant march along the bottom of the graph, right? Because the graph is auto scaling its y-axis. Another is visual alignment in time. So all these are reflecting the same time scale in a nice consistent view. So we're able to see like, hey, this spike here, right, exactly predates these other problems. I believe, if you look closer, you can see that it's, in hours or something, so it's quite suggestive, right? We have nice tracking of maximum and average tracked together. So again, we're able to see like clearly these three behaviors are correlated, right? And so that's a really, really useful way to get a quick view of what might actually be going on. And I would submit that a well-structured dashboard can do a lot more than a 2-week spike where you add a bunch of points, where you log more, where you send more where you decorate your trace information, or buying a fancy instrumentation product. I think that a little time spent to how readable and how usable your dashboards really, really matters. And the most common thing that you hear when you talk about people who work in these tools all the time is they say, I am clicking between a lot of tabs to try and put this information together. Part of that is unavoidable as nature of the beast, but I think that the time that you can take to get things on, for example, to a single Grafana dashboard and be able to look at it all in one tab, really, really, I've done it myself. You end up kind of relying on that dashboard a lot more than a lot of your other, maybe even more detailed and more accurate tools, just because it lets you get a quick glance view of where you maybe should be looking. So for example, you're able to say, hey, because I'm looking at this dashboard, I'm just going to start to suspect that we have some looking to do in the area of our database, right? And all the work we're doing, like debugging how our front end code is executing, is actually probably not useful use of our time. Okay, so we're running a little short on time, and I have a few more things to go through. I wanted to talk about observability strategy here. So this is stuff we can do that's not about using a particular set of tools or set of repositories, but just is worth doing. So one is this quote that I love from Tom McLaughlin, which is, which tool should you use for infrastructure as code? Yes, you should. So infrastructure as code, right, is the concept that we're going to save some kind of template that will tell us how a new piece of infrastructure should be configured, very often for cloud services, but also for our own like orchestration or containerization systems. And much more important than what you use, right? You can use Stackery, you can use Serverless Framework or Terraform or all these other tools, is that you use something. And that's because any tool is going to give you some insight into what your configuration is that's really readable by others. It's going to give you some kind of commit history for what's changed. And that's really, really useful stuff. There is also, of course, stuff you can do for observability without tools. I'm going to move myself so we can see this glorious image from the Primitive Technology YouTube, where this guy goes out in the Australian bush and makes like little houses and kilns and bricks and stuff, all just starting with his bare hands and a pair of cargo shorts. Check out Primitive Technology if you haven't. But there's stuff you can do without purchasing a particular tool or using a particular open source tool. So structure is very, very helpful. Right, I'm running out of time, so I'm not going to get to talk about this, but this is a cool thing. Go Google, if you're looking at primitive technology, go check out forbidden crystal symmetry if you want to learn what this tile pattern is about. So a little structure goes a long way, and specifically I'm talking about thinking about structured logging. So when you go to add in those log statements, which are, I mean, for most of us are the way that we certainly do observability first, think about using structured logging rather than just saying in text what's going on, maybe dropping in a few variables. Think about having an actual consistent structure of that logging. Now, of course, there are great structured logging libraries that give you, nice kind of object-based or nice, easy notation to log a certain piece of information. This is just something you can do right from scratch. You can just say, hey, I'm going to create a state object. I'm going to write to it. I'm going to add key value pairs to it. I'm going to update them as necessary. And when I want to log something, I'm going to log out that whole object. So you can absolutely just sort of implement structured logging, right on your own. So another big piece of observability is people. So again, we have this definition of observability, which is how quickly we can analyze a particular problem. And I would say people are a key component of that. On one weekend where you add a few log lines to your production code, but also 2 of your senior developers leave the project, or 2 of your senior engineers, your ops people, or whoever leave your project, your observability just dropped significantly. The information that's stored on your dashboard and in your logging tools and all these other places stayed the same, but the ability to interpret that data just dropped. So this means, of course, we all know to do the work to try to retain people and keep our teams consistent, but also do the work to share information among your team members. Because the more you can build up everyone to feel like they're competent on the whole system, the more you're going to get to that state where you really have an observable system because you have multiple people who understand how it really works. Okay, on that charming note, that's most of my time. I, again, am Noshanika. Nika's fine if you choose not to learn how to pronounce Noshanika. I work at New Relic. You can find me on Twitter at serverlessmom and on Twitch at serverlessmom and on GitHub at serverless-mom. Thank you so much for your time. I believe I can take questions in the chat. I am, this is the pre-taped me speaking to the virtual me. Maybe I'm screaming in chat. No, I can't take questions, or I will take questions, or what have you. But yeah, go and hit me up on my Twitter DMs or come join a Twitch stream if you want to ask some follow-up questions. Thank you so much for your time, everybody.